Okay, now laws of indices. So now what are the laws? So here we have 6 laws of these indices. So here laws of indices. Now some of the laws, that means first one, multiplication laws of indices. Now according to this multiplication laws of indices, it says that whenever two or more than two algebraic terms that are to be multiplied having the same base, if their base are same and if there is algebraic terms that is to be multiplied, then in such condition their powers that are only added. You can be more clear from the example. Let me consider an example, that is x power 4 into x power 3. Here we find that this one is our algebraic terms, this one is also our algebraic terms. We find that in both these algebraic terms they have the same base, that is x. Here also we find x, here also we find x. So now here if we have to multiply these two algebraic terms, then in such condition their powers are only to be added. That means we have to write the same base, that is x, and now these powers are to be added. So 4 plus 3, that means simply we can write x power 7. So the product of this x power 4 into that is x power 3, that is x power 7. Now the second one, that is division laws of indices. Now here in the division also, as for the multiplication laws of indices, if two or more than two algebraic terms that are to be multiplied, their powers are added. So now for this division, if two or more than two algebraic terms that are to be divided, then in such condition, okay, now division laws of indices. Now for this division law of indices, here also, if we are going to divide any two or more than two algebraic terms, then in such conditions the powers of the same base, that means they are to be subtracted. We can be more clear from the example. Let me consider an example, that is x power 5 divided by x power 2. So here also we find that they have the same base. In both these algebraic terms we find the same base, that is x. Now we have to divide this, that means x power 5 that is to be divided by this x square. So here simply we have to write this base, that is x. Now here the first value, that means this is to be divided, so write this power, that is 5, and this minus 2, so it will be x power. We can take another example, that is suppose that this 2x whole power 5, okay, divided by 2x whole power 7. Okay, let me consider that this example. So now here in this example also we find that the base, that is 2x. Here we find that this 2x, that is the base, that is this whole power, that is 5. So now this whole 2x power 5 that is to be divided by this 2x whole power 7. So here the base, that is 2x, so right here 2x power this 5 and minus this 7. So it will be 2x power minus 2. This is our division laws of indices. Now the third one. Now the third one, that is power laws of indices. Okay. So now here this power law of indices, it says that sometimes we find that any algebraic terms that has already a power, and the power of that power is also given. Then in such condition, what should be done? What should be applied? Okay. So here let me consider an example, that x squared. Here we find that this algebraic terms, it already had that power, that is 2. And if we find that again the power of this power that is also given, then it means that x squared whole power 3. It means that we find the two powers, that is 2 and 3. So in such condition we have to multiply these two powers, that means 2 into 3. So simply we can write x power 6. This is the power law of indices. Now the fourth one, that is zero law of index. Zero law of index. Now according to this zero law of index, it says that if any base having the power 0, then that always equals to 1. That means here, if any value, suppose x power 0, here we find that the base that is x and the power that is 0. So simply the value of this, that will be 1. We can take another example. Suppose 2pq whole power 0. Here also this 2pq, we find that this power, that is the power for this whole value, that is 2pq. It means that this is our base. So power of the base, that is 0. It means that the value will be 1. So simply we can write here 1. Similarly, we can take another example for the constant value also. Suppose here 5 power 0. Here this 5, that is the constant value, and for this also we can say that it also plays as the base for this. Okay, so we can say that this 5 is the base as well as the constant, and the power of this base, that is 0. So simply we can write it, the value of this as 1. So this is our zero law of index. Now the fifth one, that is negative law of index. Now this negative law of index, sometimes we find that the power of the variable, or we can say the power of the constant, or simply we can say the power of the base, that is in negative form. That means the power, they are in negative, their sign is negative. Then in such condition, what should be applied? Suppose here x power minus 1. Here we find that the power of this base, that is minus 1. It means that we have to reduce, or we have to eliminate this minus sign. So in such condition, we have to take the coefficient of this x. So here the coefficient of this x, that is 1. So simply write here 1 by, and we have to take this variable, that is x, and we have to write this power. So here power, that is 1. So we should not have to write the power as 1. We can take another example. Suppose 2x power minus 3. Now here we have to eliminate this minus sign. It means for this we have to take the coefficient of this x. So what is the coefficient of this x? 2. So write here 2 by, now this base x, and now this power, that is 3. So here this minus sign, this can be eliminated. Here also minus, that is eliminated. So this is our negative law of index. Similarly, in some condition, we can also take another example, that is 1 by 2 m power minus 4. Suppose here we find that the power of this m, that is minus 4. Here this minus 4, that is the power for m only, not for this 2 also. Here 2, that is the coefficient. So here we have to reduce this, we have to eliminate this minus sign. So for this we have to take it to the numerator. So 1 into m power 4, and this 2. So this is our negative law of index. Now the last one, that is root law of index. Root law of index. Sometimes we find that some of the variable or algebraic terms, they are even inside the root value. So in such condition, how to eradicate that root sign, or how to eliminate that root sign? Suppose that example here, root m. So now here this is the symbol for a square root, that means here that is 2. Okay, so now here if you have to eliminate this root sign, then we have to write this m. So what is the power of this m? That is 1. So 1 and into, if you have to eliminate this one, then we have to take 1 by 2, because this is the square root. So write here 1 by 2. Similarly, if there is cube root and here n power 2. Then for this condition here, what is the base? M, so write here n, and the power of this m, that is 2, so write here 2. Now into, now if we have to eradicate this cube root sign, then 1, that is to be divided by this 3. Whatever the value is given here, we have to take it as the denominator value. So now solve it. So n power 2 into 1, 2 by 3. Here also we can write this as m power 1 by. So in this way we can eradicate or eliminate this root sign. So these are the 6 laws of indices. So if you have understood this one, then you can simply solve all the problems related to this chapter. We have understood, and if you have any questions about these chapters, then you can comment me, and you can also ask me. Okay, so I hope you have understood. Okay, let me solve some of the problems that you might have some problems for these chapters. I think that you might have a question that how the value of that x power 0 that equals to 1. I think most of the students, they might have this question. So let me explain that how the value of any constant or any base that their power that is 0, that always equals to 1. So here proof that x power 0. We can write this x power 0 as x power 1 minus 1. We can take any value. That means it doesn't mean that we have to take 1 minus 1. We can take 2 minus 2, 3 minus 3, 4 minus 4. You can take any value, and their result must be 0. So if we subtract 1 minus 1, then that will be 0. So now here, if we follow the rules of multiplication laws of indices, then here we can separate it individually. That means we can write this x power 1 dot x power minus 1. We can write this one. Okay, this x power 1 dot x power minus 1. If we are to multiply this one, then x same base, so right here x. Now these powers that are to be added, so 1 plus minus minus 1. That means this value is equal to this one. I have written the same steps here. Okay, so right here this x1. Now according to the negative law of index, we can change the power. That means if the power that is a negative, then we can change it. Okay, so while changing this, we have to write the coefficient of this x. So what is the coefficient of x? 1. So right here 1, and this x and the power that is 1. So now this x power 1, x power 1 cancel. So it means that therefore this x power 0 that equals 1 proved. In this way you can prove any values whose power that is 0 that always equals to. Okay. Now here some questions. Evaluate. Okay. Evaluate 27 power 1 by 3 into 64 1 by 2 into 81 3 by 4. Okay, here you are given a question that is evaluate this one. Okay, so now here we have to simplify this. So while simplifying this, we have to take it to the lowest terms. That means here we can write this 27 as 3 power 3. That means if this 3 is multiplied 3 times, then the result will be 27. So in place of this 27, write here 3 power 3, and this 1 by 3, that is the whole power. Similarly 64, it means 2 power 6. If you multiply 2 6 times, then the result that will be 64, and this 1 by 2 power. Similarly here this 81, that means 3 power 4. That means if we multiply 3 4 times, then the result will be 81, and this 3 by. Okay. Now it is in the form of power law. That means it shows the power law of index. Okay, so according to the power law of index, we have to multiply the power. So here 3 power 3 into 1 by 3, and similarly here 2 6 power 6 into 1 by 2 into 3 4 into 3 by 4. So now this 3 cancels. So right here 3, and the power that is 1. So we should not have to write this power as 1. 2 now 2 3, so 2 power 3 into here this 4 cancel 3 power 3. Now here also we find that these two values, that means this 3 and this 3 power 3, they have the same base. So now these two bases that should be multiplied. So 3, now what is the power of this 3? 1. So right here 1 and this 3. So 1 plus 3 and this 2 power 3. So here 3 power 4 into 2 power 3. So now we can also simplify, or you can also leave it here. If it is in the lowest value, that means if we can calculate that one, then we have to calculate that. If the power that are in too large, then in that condition you have to leave it. So in this way you have to solve this one. I hope that you can solve in this way. Okay, thank you class.